Welcome back to part 2 of the Getting Started series with the Reclaim the Stack platform. In this part, we are going to deploy a Rails application into our local cluster and see how that works. So for this, we will use the K command line tool. You can find this on the Reclaim the Stack organization, K repository on GitHub. Installation should be simple. If you are using Homebrew, you can just brew install it. And if not, you can try to follow these instructions. The first thing we'll need to do is to configure it by adding a context. A context is a combination of the GitHub's repo that we created in part 1, a Kubernetes cluster, and a Docker registry and namespace containing the images that we want to deploy. And in my case, I'm going to use Docker Hub as the registry and my own personal debugkeys user as the namespace. So we'll just go ahead and run the context add command and pass in the URL of the GitHub's repo. First thing, we verify that we have read and write access, and then we prompt for the name of the context, which defaults to the name of the repository, which is Reclaim the Stack here. It sounds good. Next question is which Docker registry should be used, and in this case we just use Docker Hub, which is the default, and the namespace will default to the name of the organization on GitHub, which also matches in this case, so we can proceed. We then verify that we have authentication against the registry, though do note that we cannot actually verify that we have access to this namespace in particular, so I guess you will know what you're doing here, but it's something to bear in mind. And then finally the kubectl context, which defaults to the current one, which is the one we want. So with that, we have K installed and configured. We can list the contexts with K context, and we can see that we are currently using the Reclaim the Stack context. And now, before we can actually install anything, of course, we need to have something to install. So we have also on the Reclaim the Stack organization, we have a Rails example repository, which is the application that I'm going to deploy. So let me change directory over to this Rails example. And the first thing we need to do is to build it and push it to the Docker registry. And we have a helper for that in K, build and push. And it will tell you here the command it uses, so we can have a little look at that. So it uses the modern build command of Docker, which is build x, and we pass in Docker file as a default file. If it cannot find the Docker file, it also falls back to dockerfile.k, or rather the other way around. If it finds dockerfile.k or .kubernetes, those will take precedence, and finally it falls back to the Docker file. It auto-detects if there is a Ruby version file. It passes in Ruby version as the build arg, which is also part of the Rails default Docker file, shipping in Rails 7.1. Platform will be Linux AMD 64, which is also the reason this will take forever to build on macOS because of the emulation involved. And for tags, it uses the Docker repo registry that we configured during the context configuration, and uses the name of the repository. And for tags, it uses latest, and also the one that we actually make use of most of the time is the SHA. So that's the current Git SHA, which is similar to what you would see on, for example, Heroku, that the current deployed SHA becomes the version which is deployed. We also have some cache from and cache to here. So in case we do subsequent builds, you can also fetch the cache from the registry itself. And we do progress plain, so we can actually see what's going on. The default doesn't really show you, in case something would go wrong. It's nice to have the debug output. And then let's just probably fast forward this part in the video. So now we completed the build, and the next thing that this K command will do for us is to push the built image onto the registry. And we're done. So reloading here, let's just confirm that we can see the repository, and there it is. So we should be now able to deploy this. Okay, so now that we have pushed our Docker image to the registry, we are now ready to try and see if we can run it inside the Kubernetes cluster. But first we need to create an application to run the container in. And for this, let's look at the kgenerate command. So kgenerate, it has a few different generators here that can help us to manage our applications and resources. So first off, we need to generate an application, and I'm going to give it the same name as the Rails app itself to keep things straightforward. And we can see that it generated an application skeleton for us. So inside the applications folder, we get a folder with the name of our application. And then we have a chart YAML, a values YAML, and a templates folder. If you are familiar with Kubernetes, you will recognize this as a Helm chart. And Helm is something that allows us to do some nice templating within the applications, which you will see later on. For now, we will just commit this. You can see that the chart name is Rails example, but that's about the only thing of interest in here. Applications and Rails example. And let's push this, and we can go back to Argo dashboard and see if we will get this application here. And sure enough, we have our empty Rails example application. Just a quick detour here to explain how this actually ends up in Argo. So in our Argo CD root that we used when bootstrapping, we have defined an application set. And the application set, it basically takes a path and looks at everything under this path, and then it creates an application from whatever is there using a template. So you can think of application set as being like a generator of applications. And that's how we now have this inside of Argo. But an empty application isn't very interesting. So let's head over back and look at kgenerate. And you'll see that we have another generator called deployment. A deployment you can think of as something that runs your container inside of the cluster with some kind of command. So roughly equivalent to the proc file in a Heroku setup, like web, Sidekiq, etc. If we run this on our Rails example application here, we can get to choose between web, Sidekiq, and other. These are some default templates. We'll go ahead and choose web. And we can see that we created a deployment web template. And also we got some suggestions of things to put inside of our values YAML configuration. So let's open up values YAML and see what we have here. First off, we have an image, which you can see is a reference to the image that we pushed. And by default, we use the latest tag. Later on, this will always use the SHA for specific versions, but as a starting point, we use latest, since we know that's something that we have available. Then we have an entries to deployments, where we can specify the number of replicas to run for this deployment, and also how much memory and CPU to allocate per replica. So you can increase the replicas if you want more scalability or high availability, etc. You also have an environment variable section, and these environment variables will override only for this deployment. So I like to keep things here which are related to the scaling. For example, web concurrency, which you can use to define the number of Rails server processes and make sure that that correlates to, for example, how much CPU we're allocating. We can also enable the readiness probe path. This should be set to a path that Kubernetes will make a request to determine if your deployment is successfully up and running. And whenever that's up and running, then Kubernetes knows that, okay, now I can start routing traffic to the new deployed pod. Since we're using Rails 7.1, we will have this /up path by default. And I will go ahead and remove these other default things because we're fine with the defaults. Next, we have a suggestion to add an entry to the enfrom. Enfrom can be used to inherit environment variables from secrets inside our GitOps repo. So by convention, we like to use a secret with the same name as the application, but we have to create this separately with this command. So let's go ahead and do that. ksecretscreate will open up the configured editor and allow you to type in whatever initial values you want to have. For example, the Rails environment, secret key base, etc. So once you save and quit that window, then K will go ahead and commit that into the GitOps repo. And finally, we have a ingress configuration that we can add to expose our web service to the internet. So let's go ahead and open the config file, and we can paste this in here up under applications. And hopefully this is correct for you. Basically, we make a guess of the domain that you want to deploy to based on what you have previously configured here. But if you're putting this application somewhere else, you just have to configure it to have the correct host name. And internally, we have the service Rails example-web. And to see how that happens, we can open up the deployment web template that was generated. And you can look at this at your own leisure. But this is first of all, the deployment resource and a bunch of templating here. And finally, we also add a service and this is only for the web deployments. We have a service so that we can communicate through the network. And this gets the name of the application and the web suffix. So these templates, if you're inclined, you can look at them. If you're not so inclined, then feel free to just not worry and just trust us that we hopefully did a good job setting them up for you. The idea is that at the end of the day, you only need to kind of worry about what's in values, and you don't have to worry about your templates too much. Now with all this done, let's commit and push. Rails example, add web deployment. And once we push, we will see that we actually have a rejection. So how is that? Let's pull and rebase and find out. If we do look at the log here, we can see that we have a commit that we didn't do ourselves, but that K did for us. So K, when we added the shared secret, it committed the secret and it also pushed it. So that's how we had to rebase here. And K manages its own clone of the repo, which should be sort of kept hidden away because you don't want to interfere with the things that K needs to automate. So if you're interested, that actually lives under the K. So we can see that we have reclaimed the stack repo is cloned under the .k directory. But let's head into, let's push first, of course. And now let's see if we get something happening in Argo. And looks like we're getting a sync here, and Argo starts to apply all these templates that we added. We have our deployment here, our Rails example web deployment. And as you can see, it's in progress here. We can have a look, see at the events. Currently, it looks like we're busy booting. So the readiness probe is currently failing. If we look at the logs here, we can see that we're still waiting for the server to boot. Typically, this would be very, very fast, but since we're running this whole Docker engine in emulated AMD 64 mode, it's a bit slow. But as soon as this is up and running, then the readiness probe should go green, and we should be good to go here. So actually, yeah, that's already done. Looks like the log wasn't really tailing there. So we're fully green, and we have our app deployed. And hopefully we can also reach it on the internet. Let's find out. We have the Rails example app here on reclaim the stack menus.dev. And what happens? It works, but it also doesn't work. So why doesn't it work? Let's find out. Klogs, Rails example. And let's make another request and see what we get. Of course, we don't have a Postgres database yet. So that seems logical that we would fail. So let's go ahead and add that. All right, so kgenerate again, and we can now look at the last type of generator, which is a resource. So this would be typically like your Postgres, your Redis, and such things. So at the moment we have templates for Postgres and Redis. Let's add a Postgres database. And like before, we can see that we had a template generated for Postgres. And we also have some more suggestions for values YAML. So let's copy paste this. And this will now be in addition to our resources hash. So again, we can specify now for Postgres, do we want it to be highly available? Not in this case, since we're running just a single node. We have some default memory and CPU and disk allocation. And we also have some raw Postgres config here. And a suggestion to generate these values via this Postgres tuner website. So you can basically add how many CPUs and how much memory, and you get some good default values that you can enter here. But this looks good for us at the moment, so we'll just go ahead. And finally, we have an entry to the root end section. So previously we had added some environment variables from a secret. We also had this override for web, but this section it will apply to all the deployments within this application. And the reason that we put this database URL here and not inside of the Rails example is because this allows us to use secret key references for this particular value. And this secret here is something that the Postgres operator will generate for us. So this means that when we commit this now, then as soon as the secret is available, then we can resolve the database URL and we can kind of get everything deployed smoothly like that. So let's commit this and see what happens. Again, heading back over to Argo CD, and now we should see a bit of an explosion here as we get the Postgres operator recognizing that it should create a Postgres cluster for us. So this is a lot of resources. Thankfully, we don't have to worry about any of this ourselves because the operator manages it for us. So this is all kinds of things. We have automated backups, etc. going here for us. So whenever this is done, then we should be able to see the pod starting, and when that is done and everything here is green, then we should be able to try again here with our web application. So that's the green signal now for the new web pod. And we can see also here that we didn't start terminating the old one until this one was green. So if the new one would have failed for whatever reason, then we would have kept the old one going, so we didn't have any downtime. So now let's do the klogs again and reload and see what happens next. So we're sorry again, but maybe there's a new error. So now the error is that the relation posts does not exist. Of course, we haven't run any database migrations yet. So let's go ahead and use another command for that. Krun, name of the application, and then the command to run. So in this case, bin rails db schema load. And once this is done, we go back here and reload, and voila, we are now up and running. We have our little Rails blog. We can make a new post, reclaim the stack. This is the way. Great post. Good stuff. So good progress so far. But we are not done yet. Let's head over here to links, where I have added something which is a bit more demanding. So links, here we can just throw in a URL, create link. And we're sorry again, something went wrong. Let's have a look at the logs and see if we can find any error here. Sidekiq 7 connecting to Redis, error, failed in queuing. Redis client cannot connect error. So we need a Redis database. If you've been paying attention, then you might guess what's coming next. We now generate a resource again, but this time we go with Redis. And we get our Redis template, and we get some values to add. We already have our values open here. So let's just copy paste the new Redis entry here. And we can turn these down since we are not doing a high available cluster. And here you can also specify now memory, CPU, and disk for Redis. We just want a tiny little instance, so this looks good. And finally, we need to add, similar to what we did on the database URL, we also have Redis URL and Sentinel URL. Now, the Redis URL you might be familiar with from before. That's a default environment variable that gets used by the Redis client by default. Sentinel URL is something which is nice to use for high availability. You can achieve 0 downtime if you implement some logic for handling the Sentinel URL. However, that is out of the scope for now, but it can be good to know that this is available, so we'll just leave it in for now. And now we can go ahead and commit our Redis database. Push, and let's go over to Argo CD and see the refreshing here. So this time around we should see a new resource getting created. This is the Redis failover, and we start the sync. So the Redis operator will now find that we added the Redis failover, and it starts to create all these resources to run Redis for us. And as soon as this is done, then we should be good to go again. I can also, I guess, mention actually about these values, that here we are not actually including any secrets at all. We just spawn our Redis clusters without any password because we trust the internal network to be secure. If you want, you could change the Redis templating for your own needs if you want to add passwords, etc. But for simplicity, we're also keeping like these database URLs together here under env, but we could also put them directly into the Rails example secret if we so desired. Looks like everything is green. We are waiting for the pod to boot. Unless this is actually the terminating one. Okay, there we're green and we're terminating the old one. And with that, we should be able to try creating this link again. So here we are. Let's see what happens. Create link. And we have successfully created a link, and we have enqueued a job to resolve this via Sidekiq. However, we are not running Sidekiq yet, so let's add that. All right, so you might have guessed it already. We are heading back to kgenerate, and this time we create a deployment. And we go for the Sidekiq type. As usual, we have a template generated and some sample configuration. So let's head into our values YAML and add the Sidekiq deployment. And these values here, they work just like on the web deployment. We can remove the custom command because we are fine with running bundle exec Sidekiq. So let's just deploy this. There we go. And heading back to Argo, we should see the refresh triggering there and the sync. We can see our new Sidekiq deployment is starting up, the replica set and the pod. Let's actually have a look here at the logs for Sidekiq. So there we go. So we had some things happening there. Let's go back to our app and boom, we have now crawled this URL, which is basically what this app does. It sends a job over to Sidekiq, it crawls the URL, gets some open graph, thumbnail and title, etc., and streams it back into the UI via Hotwire, which is also going through Redis. So for fun, we can head over to Medium and maybe put another link in here. See see if it works. So we go to pending state, and then in a moment we should see it getting crawled, and we get the Open Graph representation there. So that's cool. We have deployed our Rails application. We have added a web deployment, a Postgres database, a Redis database, and finally the Sidekiq worker. All good. So with that done, I think as a next step we can have a look at some nice commands that we can use with K.